am Kunal Levle from Diploma College of Engineering, Pune. So today I am going to explain an important topic in data communication under the guidance of Sweta Devdas ma'am, which is data conversion. So this is all about my introduction. So let's start now. In communication systems, data is not always in the same form. Sometimes it is digital, sometimes analog. But to transmit data from one device to another, we must convert it into a suitable form. This process is called data conversion. There are mainly two types we will discuss today. First is digital to digital conversion and second is analog to digital conversion. So let us discuss about digital to digital conversion. Digital to digital conversion means converting digital data into digital signals. Digital data is in the form of binary bits, that is zeros and ones. But these bits cannot directly travel through a medium. So we convert them into electrical signals. So techniques. There are three main techniques. First is line coding. Line coding converts binary data into digital signals. Examples are NRZ, that is non-return to zero, and second is Manchester encoding. In Manchester encoding, each bit has a transition which helps in synchronization. Second is block coding. Block coding adds extra bits to detect errors. Examples, 4 bits are converted into 5 bits. Third is scrambling. Scrambling avoids long sequences of zeros and ones because they can cause synchronization problems. Examples are when you send data over the internet using Ethernet, digital to digital conversion is used. And second type of data conversion is analog to digital conversion. So analog to digital conversion means converting analog signals into digital data. Analog signals are continuous signals like human voice, temperature, and sound waves. Computers cannot understand analog signals, so we need to convert them into digital form. So this is the diagram about the steps involved in analog to digital conversion. So let us talk about each step in detail. First is sampling. We measure the digital signal at regular intervals. Examples, taking snapshots of sound. Second is quantization. We convert sample values into fixed levels. This introduces a small error called quantization error. Third is encoding. We convert the quantized values into binary numbers. Example is when you record your voice using the mobile phone, the microphone converts analog sound into digital data. Now let's look at a short video of converting an analog signal to a digital. So now it's time to have a look at some live demo examples. This is image 1, this is image 2, and this is image 3. So image 1, the setup, identifies the two important starting points. The blue text on the monitor represents old digital data, legacy, and the green waves coming from the sensor represents raw continuous physical signals, analog. Image 2, digital to digital, shows the blue to orange migration. The computer takes the old blue digital archives and converts them into a modern orange JSON/cloud format so different softwares can read it. Image 3, analog to digital, shows the green to bar translation. The ADC converter box captures the Viva green analog signal from the sensor and turns it into a precise digital bars that a computer can calculate and store. That's about the live demo examples. Now, let us understand the difference between analog and digital signal in a funny way.
See, Mary, analog signals are continuous flow of electricity. For example, take this light bulb. If I keep playing with the dimmer, it is a continuous increase and decrease in the light of the bulb. Oh, so that's why analog signals are shown in waveform, where if this is light and this is dark, then these are infinite small changes to the intensity of light. Absolutely right. You are smarter than you think. Now, if I switch the light on and off like this, it is similar to a digital signal, where the signal has only two values, on or off. Now I understand these graphs. This means in digital, this is on and this is off. So the graph represents only two values, one off and the other on. Precisely, Miri. Now I hope you understand.
So let us compare this all information recorded in a video within 1 minute. So digital to digital conversion converts binary data into signals for transmission, and analog to digital conversion converts real world signals into binary data. So now it's time to practice some questions based on today's topic. So first question is, what is data conversion? So answer is, data conversion is the process of converting data from one form to another for transmission or processing. And second question is, what is digital to digital conversion? Answer is, it is a process of converting digital data into digital signals. Third question is, what are the techniques using digital to digital conversion? So answer is line coding, block coding and scrambling. So fourth question is, what is analog to digital conversion? Answer is, it is a process of converting analog signals into digital data. And fifth question is, what are the steps in analog to digital conversion? Answer is sampling, quantization and encoding. Sixth question is, give a real life example of analog to digital conversion. Answer is voice recording using a microphone. So conclusion about today's overall topic is, data conversion is essential in a communication system. Digital to digital conversion helps in transmitting binary data efficiently, while analog to digital conversion allows real-world signals to proceed by computers. Understanding these concepts is very important in networking and electronics. So thank you. That's it about today's topic. So keep watching and keep exploring. Thank you.